Hey everyone, this is your Zephyr weekly podcast. I'm Benjamin.
And I'm Fabio.
Welcome for episode 7, I think, of
7?
the podcast. Yes,
Yeah, I think it's
already.
7.
Yep. We will stop counting, I promise. But yeah, it feels great to stick to the schedule. Fabio, are you still in Japan?
Yeah. I've been out of my home office for a couple of weeks, and yeah, if you didn't notice, I guess we managed to keep a decent quality on the mobile recording setup. So yeah, my last week in Japan, and then back to Ireland.
Right. You were there for like vacation, personal time?
Yeah, this is one of my weird relaxing vacation in quote marks. I actually run a running race, like it was a 100-mile running race, going from some random town inland to Lake Biwa. And yeah, this was a mountain race, 10,000-meter elevation gain as well. So it wasn't exactly relaxing. It took me 36 hours. I'm pretty wrecked. So yeah,
Yeah, I'm sure.
happy to go back, just sitting on my computer writing code for a while.
Yeah, I'm sure you're still recovering from it. Well, when you told me last week, I was like, 100, and I stopped at 100. So I was like, in my head, I was like, oh, 100 kilometers. Oh, that's fine. Like I do this like every week with my car. And then I was
Car.
like, and then you sent me your Strava or whatever, like the recap. And I was like, oh, wow, that was, what does it say? 160. Oh, wow. Okay. That was miles. Yeah,
Yeah,
that's
it's
probably.
yeah, it's a weird thing, right? It's a distance where you normally drive and think about taking some stop in the middle, but no, it's doable. If I can do it, given enough training, anyone can.
So,
eh,
so do you manage to like, do you have some Zephyr goodies with you when you run, like as a
I
like a lucky charm
I
sort of thing,
I
or?
absolutely did. I think that my only excuse for bringing ultra running into this podcast is if I have some Zephyr-based electronics with me, and I very much did. And actually, I've been doing quite a few of these races, and I've been running with some Zephyr-based stuff for a long time, many years, in fact. Some people saw it because I can't seem to be able to shut up about it. So the race goes through the night, right? You don't sleep, you just run. So I have a headlamp, and the headlamp that you normally buy have a battery that lasts a couple of hours, and this said 10 hours of darkness. So you can swap batteries, but in this case, I had a headlamp laptop plugged to a power bank, and I designed my own headlamp. Because why wouldn't you? And yeah, the one I did, obviously, like everything I do this day, runs Zephyr. So this is a simple board with an STM32C071, and it has two LED power converter and two white LEDs, and then there's some lenses that you can buy off the shelf. These are from a Finnish company called Ledil. If you want to do some illumination project, this is worth having a look because they're proper plastic polycarbonate, I think, lens, and you have various options for the beam. You can have like spotlight, soft spot, which is what I used, but you can have like oval beams, which is interesting because they give you side vision, which I didn't realize was a thing, or various wide, ultra wide, stuff like that.
And then a bunch of 3D printed casing, and you're in
Yeah,
business.
Yeah, the chassis was 3D printed, and since this has to survive rain, it was actually glued together. So I'm in a bit of a situation where if I upload a bad firmware, I need to cut it open and reprint it. Yeah, so the headlamp worked perfectly well, I have to say. It survived 1.5 night that I needed it. And yeah, I'm throwing the design in the bin and I'm redoing it from scratch. This is the sickness of doing electronics firmware and 3D design. You're never happy, right? So you use it once and you're like, oh, I could improve a couple of things. So it's simple design, right? Just a microcontroller and two power converter. I decided that I do not need two lights, two LEDs and two different beams, which I initially thought I did. But I only need one, so I can do it smaller and lighter. But the most annoying thing I had is that if you shut it off, it's powered from an external power bank. And if you shut it off, the power bank is going to go in low power and shut off after 1 minute. So
Right.
you go to
I see.
you go to a checkpoint to turn the light off, and then you're ready to go, and you need to fetch it from your back and plug it and unplug it. So I need to put like a ballast circuit to keep the power bank on. But apart from that, very good design. Does it need Zephyr? Absolutely not. It has like one button and two PWM. There is no reason to run an RTOS, but you know what, Benjamin? It's actually really cool to have the whole the whole subsystem thing, because the code is extremely simple and I can port the logic to everything really. In fact, this is my second headlamp that I do. The first one was actually only a redesign of the electronics for a commercial lamp, and it had an RF52832, and it had Bluetooth, and it was connected to my watch to show me the battery level. So that was a much, much more complicated design. And I had this feature where if I stop the watch, the light shuts off. And then when I restart the watch, the light turns on again. So there was the overcomplicated design with the battery that lasts 2 hours and you have to change it. And I actually used it for 3 years, I think, until it died. It drowned. The membrane for the button failed and it got full of water. And that was it. Yeah. So that was my race.
And so, what was your? So you finished, I guess, is already the achievement. Like, how did you rank?
Oh yeah. So the race was I think 320 people, and I finished fourth.
So five died.
I think no,
Two hundred
Benjamin,
didn't finish.
nobody died. I think about 200, 220 finished. This was a very, very hard race, but there was a fairly generous cutoff. We had 56 hours, I think, to finish this one, and it took me 36. But people do it a bit slowly. Maybe they take their own time, they sleep more, they take their time at the checkpoint. So yeah, I finished in the top. Yeah, between 10 and 20%, which is where I usually tend to finish. I'm good enough,
Yeah, that's
decent,
actually pretty
but
good.
yeah,
Congrats.
I'm delighted.
And so headed back to Europe in.
Oh yeah, looking forward to it.
Awesome.
Good. What's up with you, Benjamin?
Well, so we have the feature freeze coming up. I think I misspoke last week, or like was vague. So it shouldn't have been, but it was maybe blurry in my head. Feeder freeze is coming up next Friday on the 24th. I hope I get this right this time. So yeah, people are lining up there. Sort of last minute PRs and so on. Some of which I guess we will cover later during the show. But one thing I finally found some time to play with it. I've been playing with the board catalog a bit more. I don't remember when we introduced it, but a few releases ago, like this ability to search boards by vendor and by, like, I want a board from, say, ST with a display. I kind of vaguely remember that the name starts with whatever, and I mean, searching as you would on Mouser or Funnel or whatever. But now what I'm considering adding, and I will link to the pull request, which I hope should be pretty non-controversial and will merge by the time the release is out, is the ability to search by to search and find and discover boards that contain and use a particular binding, have a particular device tree compatible in them. So say I I want to play with this accelerometer from ST, like STMLS, whatever. What are some of the boards that already support it, and like being able to search quickly for that, or even things like since the device tree contains lots of things, including the SoC itself, what are all the boards that have a Cortex-M55 in them? Because that's what I want to, like, I don't know, I want to evaluate the support for Cortex-M55 in Zephyr. So yeah, this will be quite nice, and also cross-referencing when you're browsing the documentation of a whatever a binding, or like getting a list of all the boards that use the binding. It should be pretty cool. I think, I hope. So yeah, there's that. There's I think I might have mentioned that I'm also working on like with the release coming up, trying to think about cool demos to have featured in the announcement blog post and so on. What else? There's kind of a brain dump here, but there's also a elector. I think elector with a K. Many people, I think, in Europe would know what this is. Like it's an actual paper magazine. They have lots of online material as well. They do a Zephyr conference on November the 5th. So like a full
Where
day
is it?
Zephyr conference. It's online,
Oh,
live streamed, with quite a nice lineup. I mean, I'm biased maybe because I'm speaking there, but it's I think it's gonna be quite nice. I actually have so I think they charge a small amount for it, but I have a discount code that I'm happy to put in the podcast notes for people to use. Yeah, and yeah, I will basically be talking about. Um, I mean, you, Fabio, you know them because you're like deep in the code. But there's just so many things in Zephyr, so many tools and like little scripts and like tips and tricks that can make one's life much easier. Except that you don't always know that those things are there,
yeah.
like those
And
West build dash T something,
in,
and that something can be like there's lots of really cool stuff. Like you want to see the RAM or the flash footprint of your application, or you want to dig into the you want to sort of like get a dump of like all the different drivers and how and when they the init code kicks in. You can do west build dash T init levels. I think you're the guy behind that, Fabio, and
yeah,
just so many
Roberto.
other things like Twister. People think about Twister for testing, for like I would say basic unit or integration testing, but we have like all those harnesses for testing shell commands or for testing power consumption of your designs, etc., etc. So that's yeah, trying to sort of like yeah do like summarize some of those cool tips and tricks. I'm sure I will be missing some, but that's what I will be speaking about.
Yeah, that's gonna be a good presentation. There are a lot of tools that people added direct support. Like some of them, you can use them without explicit support from the build system, but having support on the build system make it much more convenient to use. For example, like Valgrind,
Yeah.
Undersizer,
Yes.
the RAM and flash introspection, and it's hard to find them. And sometimes you find them only after you needed it already, right? This was the story for me with Valgrind. I found a bug and told it to Alberto, and Alberto was like, this would have found it immediately, and it did for other instances. A good job.
Yeah. So, but actually, you're making a really good point. So I hope the talk will be useful and insightful for people. Uh, but yeah, we should probably be even better at making sure that this is also like really clearly featured in the documentation. I think it is for many of those tools. Some of them are it's there, but we could make them even more prominent. Like all those SCAs, like all the static code analyzer tools for easily like enabling and running your code through code checker and through Coverity, if you use Coverity, like all that kind of stuff. Like, it's really good, but yeah, you don't necessarily know it exists. And for Valgrind specifically, maybe we could have something in the doc because I don't think we do.
Mm.
So yeah, looking forward to that. And as another thing worth mentioning, this is pretty much like this week is pretty much the deadline for filling out the developer survey. We're doing good in terms of responses, but really, we could always use your help in terms of like, if you didn't already take the survey, please do. And if you could spend a minute sharing with your colleagues, with your network, that that really makes a difference. Like I'm sorry if I insist, but that those yeah, the more data points we have, the better, and we will be like closing the survey like really in the next few days. So as you are listening this, please take it if you haven't, and then look for the the results that we will start sharing over the next few weeks and discuss it with the TSC and the community at large. It'll be interesting to dig into it.
We're probably gonna have an episode on the responses. I guess there's usually some good material in the developer survey.
Yep. Yeah. That's a really good point. Yeah, we should. We will certainly probably highlight some of the findings and discuss them and maybe argue about them, because sometimes it's like, yeah, like there's always like really good stuff. So yeah, with that, I think Fabio, I wanted to ask you. I know that you play a lot with hardware, usually, and I'm surprised we didn't talk about keyboards yet, because usually there's like this one way or the other. There's always keyboard into the mix. How about we talk about mice this week? You were pinging me a few times over the past few weeks. It feels like there's some like really cool open hardware projects out there. I mean, keyboards has been a thing for a long time, but mice as well. I think you've spotted some interesting projects, some of which might already be using Zephyr. Some of them could. I think it
some
would should probably. So yeah, I would love to hear more about your findings and pick your brain about like what's the hardware involved in those, and yeah, like what's out there.
Yeah, I've seen a few like so this few years. All the rage have been on mechanical keyboards and keyboards, right? I think it's probably been going on for a while, and since people started to convert the IBM Model M to work with modern computer, and then the whole custom clickety keyboard craze picked on, and seems like mice have been left behind for a bit. I'm not entirely sure why. I find them a bit more interesting, if anything. But yeah, there is some movement. And the two most popular firmware for keyboard, QMK and ZNK, actually do support pointing devices. So mice, trackball, and trackpads primarily. And yeah, there's been some project that I've been studying for a while, and some of them which I made, and some of which I've remade, which I wanted to talk about. So the first thing that I wanted to point out, and this is mainly to give ideas to people that maybe exhausted the keyboard topic already and want to look into completing their desktop setup. So the first one, which in my opinion is the most complete from a product point of view, is the Ploopy project, which does not use Zephyr, but maybe should. Right. This I think it's a Canadian guy that does this completely custom 3D printed electronic design, and they are open source. He uses Altium for the hardware, which makes it without paying to rework. But yeah, they're very interesting, and the guy has the full set of pointing devices. So he has a mouse, multiple trackballs in every form that you can imagine, a trackpad, and a knob. And the knob is maybe the more interesting one. So he started with AVR QNK, and these days it seems like the standard setup is the RP2040, unsurprisingly.
So that would be wired typically then?
They are all wired, and this is actually the reason why I think that this should run Zephyr, because there's a lot of, if you follow the project, there's a lot of requests for making them wireless. And it's not going to happen with QNK. It's just not going to happen. I think that there are some wireless setup for QNK, but they use those weird module with the stack offloaded and a UART interface, and the stack on the module not great. So they're good design. I think if you're looking into inspiration for building any of those type of device, take a look. The thing that I think he really got wrong is the scroll wheel implementation. I don't know why. It's weird. He uses an optical scroll wheel, but he samples the signal with the ADC, which makes the polling rate very low. So a friend of mine actually has one of that device, and it told me that it loses steps, and I'm very much unsurprised. But yeah, beside that, they look very nice. The design is excellent, both the 3D printing and the electronic board. Yes, there's some design where the circuit board curves around these are ergonomic devices, right? So all of the 3D design is ergonomic. There are parts that bend in the 3D print, and the circuit board is curved in some of them as well. Like he actually uses a rigid circuit board doing an S, and then you force it through the shape and hope it doesn't break, and apparently it doesn't. So very interesting. Now, the mouse uses an RP2040, and I know that people from the Discord ported ZMK on it because they wanted some feature. So I think that there may be a future where they decide to do a wireless version. And actually, I do run one of their mice myself. I did the stock design for the 3D printed chassis, and then I've redone my own electronics, and I do have a wireless version of the mouse using an NRF 52833. And I yet to use a different mouse sensor because the one that he uses takes like 22 milliamps. It's completely unsuitable for battery powered operation, but for wired it works all right. Go ahead,
Right.
Miller.
And so I guess when you start playing with those, you spend like lots of hours, which I mean, this is free, but in terms of
Yeah.
the actual parts, like how much for like the optical sensor and like the things that you like need to put in there? It's reasonably cheap, right? I would hope.
That is one of the problem as well, actually. Yeah. So the sensor for all of these are from Pixart, which does not sell on the usual Mouser and DigiKey. So you have to find them on AliExpress. And they're not too expensive, but you're gonna pay like between 8 and 15 euro maybe for a sensor with the optic assembly.
Wow. Okay.
It's
It's all right. Yeah.
you can buy a whole mouse for that money, right?
Hmm.
So yeah, and you need to do everything else as well. Yeah. Plus, you need a 300 euro 3D printer, but then you have a free 3D printer with the mouse. So
Right. So that's Ploopy. Okay.
Ploopy, yeah, great design. They also have a trackpad, by the way, which is the last thing that they introduced. And I didn't look much into it, but it uses a design. It's based on a design called the Peacock, which is completely open source. And I know that there is a ZMK driver for that as well. Pete did it. So there is the code out there to do a custom wireless track point, which is really cool. And the other thing that they introduced is the knob, which is it's a scroll wheel and it's high resolution. So I don't know if you ever used one, but this is something that came out, I think, with the Apple trackpad. Your standard scroll wheel clicks and does like 3 lines at a time. So USB is an extension for having a high resolution feature. It's not super simple to implement, but it's doable. And when you do that, you can do per pixel scrolling. And they actually have a knob with high resolution scrolling. It's very interesting. They use a chip called the AS5600, which we do have a driver for in Zephyr, and it's actually meant for motor, like for servo motors, to check the angle for the shaft. So good project. I hope they're going to use. I hope they're going to do wireless and do Zephyr. But if you're looking into doing one of these devices and redo the electronics from scratch and do it wireless, that would be a good one. Maybe I should publish mine because I didn't. Can't do for myself. Yeah. So here's the first one. The second one, it's actually only on a YouTube video. The guy expressed interest into actually producing it if people want to buy them, but hasn't done it yet. So this is from a channel called Engineer Bow, and we'll leave a link in the video description in the show notes. I don't think he has a name. It just says wireless high resolution scrolling, and it's interesting because it's the same sensor that Ploopy used, and it's the same concept. Basically, the guy figured that this whole high resolution thing is pretty cool. But this guy this time decided to do a wireless version of the scroll wheel, and he did a very cool YouTube video where he shows all the details for the mechanical design and all. And this is a proper weighted knob with a bearing that you can throw it and it keeps spinning. So it's really cool. Same sensor, the AS5600, This time he used an NRF 52832, and he used NRF Connect SDK. So the problem I have with this design is that the sensor, the IS5600, is not meant for battery-powered operation. So in the lowest mode, which is 10 hertz, which is very bad, takes 1.6 milliamp, and full blast takes 6 milliamp. So it's going to drain the battery real quick. The guy says that with fuse optimization, the battery lasts for a couple of weeks. And if you ask gamers, they're happy with a mouse that lasts one day, which is incomprehensible to me, but whatever. But yeah, you can't have a scroll wheel that lasts 2 weeks. And so the first hint I want to put here, if anyone is listening, if you're doing something like that, there is the perfect chip for this application, which is another chip from Pixart. It's the PAT9125EL. And yeah, I know, great podcast content. And this is an optical sensor that is designed to do digital crown wheel on watches. It's a very, very specific application. Yeah, I don't know. Don't ask me how I found it. It's a complicated story. But anyway, so it's like a mouse sensor, but it doesn't use any optics. It uses a laser, and it shoots the laser.
Isn't laser optics?
No. I'm sorry. I meant it doesn't use a lens. So if you look at this is my understanding of how it works. A normal mouse sensor that looks at your table illuminates the surface and then take an image and then see how the image move between frames. What this does is that it shoots directly on the surface, and he needs like a metallic surface, and then I think that it sees the reflection from the imperfection of the surface, which is a really weird concept. But the advantage of that is that then the tracking surface can be at only 1 millimeter, I think, from the sensor. Like the lens is normally a lot more than that. You're normally like 5 or 7, something like that. So this sensor can do high resolution tracking on a metallic surface, and it takes, I don't have the number, but it takes pretty much no power at all. It automatically sits idle and switches to high frequency. And it works extremely well for high resolution scroller. And I can tell you that it does because I have it on my mouse. It does exactly that. And the battery lasts for months. I wouldn't be able to tell you how long it lasts because I forget.
Wow. And we have a driver in Zephyr for that one.
Yeah, I wrote it.
Cool. Okay.
So yeah, if you're looking to do a device like that, this is the chip. Now the bad part. Yeah, it's only on AliExpress. There are quite a few suppliers, though. I checked before we started recording. It's also a bit of a pain to solder. It's one of those chip with the pad on the bottom that do not extend on the side, if you know what I mean. It's LGA, so it needs a bit of love to be soldered. Ideally, it needs stencils. But it's doable. I did few boards with it by hand with just a hot plate and solder dispensed with a syringe. Took a couple of tries. Very good sensor. We have an upstream driver. Yeah, use it. It's good. So the last, yeah,
that's cool. Really cool. And so it feels like we have ZMK. Like someone should start ZMM or something, or like what's that?
The NK has support for pointers already. You can do mice with them, and people started to do layers for changing the sensor behavior, like sniper mode, things like that. So it looks like ZNK is going to become a thing. Yeah,
awesome.
Yeah, and the third project I'm going to present, it's I forgot the name, modulo something. Oh damn it! I forgot the name of the project. Modomouse. Okay, so this is another YouTube only thing for now. The guy hasn't published the source code yet, but he will, apparently. So this is the opposite of the previous stuff. So it's still wireless, but this is meant to be a gaming mouse. So the main thing is high update rate, because you need to have apparently bare minimum 1,000 hertz update. Probably 4,000 these days if you're really hardcore, 8,000, which is the limit of USB high speed. I don't know why people think they need this, to be perfectly honest, but who am I to say they're wrong? Anyway, so this guy is doing fully open source modular gaming mouse using Zephyr. Again, NRF Connect SDK. This time he's going for a dongle design, because with Bluetooth Low Energy are kind of limited on the update rate. The exact number is a bit limited. The interval for getting the radio gives you like 125 hertz, but you can transmit multiple time in that period, because in the setup that I run, I can do more than that, because you can have more update when you're on the radio. But anyway, this guy is gonna do dongle, so he's gonna get the full 1,000 hertz. It looks like it's going to be a good platform for doing a gaming mouse. He's using a wired sensor, the PAW3395, which is again not meant for battery powered operation, so it's not going to have a great battery life, but it's still not too bad. 1.3, 1.7 milliamp. It's unclear whether the firmware is going to be released or not, because some of these sensors need a firmware, and the license is unclear. I know that NRF Connect SDK ships with a couple of firmware, so there's probably something about it, but upstream it would be a problem. You would need permission from them to include them. So yeah, these are three good ones if you're looking into doing some hardware. I think I'm going to spend a couple of more word on what I am running, since I have some interesting setup. And yeah, so the first, I have two mice that I currently use. One is based on the Ploopy mouse, custom electronics, and it has PNW 3360, which is meant to go for wireless operation. And the only problem is that when you let it idle for too long, when you move it for the first time, it needs to wake up, and it's noticeable, but the battery lasts for months again, and it's a decent design. And on that one, I said that the scroll wheel wasn't a great implementation. I ended up using a normal mechanical encoder scroll wheel, so I had to modify the 3D design as well. The one I am really, really proud of is my primary mouse is actually, I replaced the electronics on a Logitech G3, which is one of the latest classic pilot shape. And I had that mouse for like 20 years, and I never liked the sensor, but I do now. And this one now runs an NRF52833. For the sensor, it runs a PAW3222. How many two? 3222. This chip is a bit of a problem. So we have a driver for that in upstream Zephyr as well. I wrote it just to make it perfectly clear. I don't have any contact with Pixart, so I didn't have any documentation for it. I soldered it on a board. I dumped the default register, and I realized that it's the same register set that an existing driver in Nordic Connect SDK. So I just re-implemented it from scratch using that. Now the problem with that specific sensor is that it's very hard to find. It's on AliExpress, cost, I can't remember. I don't think it was too expensive, but the problem is that it's a BGA, so you need to have a solid setup for hand soldering it. But there's a guy that make modules. I have to say, I actually made my own module as well, and I was meaning to maybe put it online at some point, but I never did. So yeah, once again, I did a lot
You
of work
should.
myself. Yeah, I know, and it works so well. The switch from idle to movement is unnoticeable, and it takes 0.3 milliamps. The battery lasts forever. I love it. And for the scroll wheel, I'm running the chip I mentioned, the PAT9125EL, and that one is on a custom 3D printed assembly that replaces the normal scroll wheel, and it's on a ball bearing, so you can throw it and it goes down forever. It is really cool. I love that mouse. One day I'll bring it to the conference, to the Zephyr Developer Summit, and show it up, because it works incredibly well. So yeah, mice, cool. Life doesn't end on keyboards.
The doom scrolling mouse, you should call it.
Oh, somebody did Google it up. Somebody did a device like that, the doom scroller. I'm not gonna talk about it because I don't know much about it, but it was a thing.
Cool. So yeah, no, put the stuff on GitHub. Give it a name too, because like
Oh, I
you
know.
mentioned a few projects that don't have a name. But yeah, no, that's really cool. Those are really nice sensors. It's nice to have support in Zephyr as well. That makes also
Yeah.
for a great showcase of like the low power capabilities and exercising power management and stuff. So that's pretty cool. Should we switch gears and go through some of the noteworthy PRs and changes we both
Yeah.
spotted this week?
Yeah. What's new?
Cool. Well, we can talk about the boards as always, boards and drivers. One thing that I spotted is once in a while, I mean more often than not, actually, some people in the community decide that they want to be awesome and start contributing like really good in-depth documentation. This week, I was really happy to see that Mathieu from ST, he did some really great work documenting some of the low-level stuff in Zephyr, some of the so-called platform hooks that we have, like when you want to really integrate like at the really low level and get some notifications when the kernel is booting, and have some like hooks when you do early reset and like all those kind of stuff. He spent some time like really going in depth documenting all those early boot sequence hooks. I mean, I love to see that. This is like really well written content, something that was clearly missing in the documentation. I guess he realized that, scratching his own itch, was like, hey, let's fix it. So it's now merged. I will put the links in the show notes. That, I think that's only like really low level stuff, but that's also good reading for folks who want to learn more about all the low level porting layers in Zephyr and stuff. So really cool to see that. Did you spot some cool new boards?
Yeah, there's been a few actually. I think there's been 7, so one per day. So
That's usually on
yeah,
average. I think that's pretty much what we get. That's a lot actually, but yeah.
yeah. So the Arduino Q, the one we mentioned last week, it's in. So there you go. If you get an Arduino Q, you can do upstream development on it. Then there's an interesting one that I seen, the PSOC Edge E84. It has a slot for Wi-Fi and one for external memory. For a moment, I thought it was application processor CPU, but no, it's a Cortex M55. I think it has something to do with AI. I don't know anything
Okay.
more about it, but
So yeah, PSOC is that's Infineon, right?
yeah, yeah.
Okay, cool.
So yeah, we're having a look. Then we had a WIACT STM32WB55. I think this is interesting because most of the Bluetooth thing we see is Nordic. This one is ST. So it's Pro Micro style. So this could be used for keyboard or mice. And and as Bluetooth, not much more into it.
Right, and React, those are, and I think there's a few more lined up. Maybe by the time we go live, some of the same person, I think, contributed a bunch of React boards.
Yeah.
Those are like really cheap, typically, right? Like one would get them off
Yeah.
AliExpress, and those are like
Yeah,
four
it's a
or
Chinese
five
company.
euros.
They have an official store on AliExpress. I actually have one of their boards. They make really good boards. I like them. Yeah, simple. Usually not a ton of onboard features, but they're good as a building block for a project.
Yep.
Yeah. Then we had the PIC32CMJH01 Curiosity Pro. So this is the second PIC32 Cortex
Microchip,
M board.
right?
Microchip. Yeah.
Hmm.
So yeah, PIC32 is back. Arduino format board. Nothing outstanding, but it's a PIC, I guess.
Yeah, that's cool. Yeah, and we have, and this week has been, I think, rather quiet on the Shield front. But yeah, anything Arduino form factor also means that people can easily leverage the ecosystem of shields we already have, right? So
Oh yeah,
that's
terrific. And yeah, last one is the Art Pi, and we already had the Art Pi 2. and surprisingly, it does not have a Raspberry Pi chip.
Yeah, this one is weird
What?
on so many levels. Like it's called Pi, and yet it's an STM32 H7.
H7.
And something that's also quite odd, but also quite exciting, frankly, is that I think this is the sort of the reference board or one of the reference boards uh, from the RT thread community and
The,
RT thread
the
authors.
seal screen says powered by RT Thread, so it's kind of hilarious to run Zephyr on it.
I mean, I bring it. Like I think this is pretty cool that this community would be like doing this and making sure that the hardware is effectively really open to the point where they help people run other
Totally.
RTOSes on it. Which, by the way, actually, kind of an open question, and maybe Fabio, you could be one of the people behind that. I would love for us to have some kind of revamp of the good old real board, which I guess at some point was kind of the de facto reference design, if one could say so, for running Zephyr. Having some kind of first
Yeah.
party
Mm.
community designed board, I think would be really cool. But
Oh
yeah,
yeah, yeah, you're right. Yeah, we need to talk to Johan maybe, or yes, he did the original one.
or maybe
Uh,
we make it like maybe we do, I don't know, like the
yeah,
official headlamp, the Zephyr headlamp, or the official
we,
Zephyr mouse or
I
something.
mean,
But
it would be shaped like a kite, and the light would be purple. I don't know how good it would be, but yeah,
I mean,
maybe.
if we get a PCB shaped in the shape of a kite, that would be really good. We have
Yeah.
the Zephyr 10-year anniversary coming up next year.
Oh no
Like
way.
really, I mean it. Like if anyone listening is game to think about what that would mean, what that could look like to have some kind of PCB and then some like whatever. It could be even. I'm sure we could even like partner with Seed Studio or wherever, like thinking
Sponsor
outside there.
by.
But having like an
Yeah,
actual SKU of something that people can really buy on Mouser,
yeah. We need to
I
do some
think,
brainstorming, see what feature to put in it.
yeah, that's the challenge. Because like if we cannot put everything, probably that wouldn't work. Like of course, Zephyr is really strong at all things Bluetooth, but then there's
Yeah,
also
net,
like Wi-Fi, and there's also like
Wi-Fi,
displays and input and
Ethernet.
ADCs and DACs and blah blah blah.
Yeah,
But I think.
and you could do video encoding.
Oh right, yeah, that's actually yeah, but and then we cannot put everything on a like a $20 dev kit, but yeah, video is only a thing. There's some new drivers slash accelerators that were merged, like what some
Yeah,
STM32 stuff, right?
so it looks like if you are the lucky owner of an STM32 N6570, which I think it's the
I do, I
A.
am, I
Oh,
have one,
damn
I
it.
think I do.
Well, it looks like you can now do hardware accelerated H.264 and in the future JPEG encoding, which is cool.
Yeah, that's really, really. I haven't had a chance to look at the code and the pull requests. But yeah, that's really nice to see because historically, some of the code and samples we have around video, etc., it feels. I mean, for the lack of a better word, I will say it feels wrong that some of those code samples are like, yeah, okay, this is going to be doing video, but the sample is like 160 by 120 pixel, really low
Right.
quality, and they're like, okay, but probably people have use cases where they need more than that, and like they might want to look at HD and so on, and so going towards
Yeah.
moving towards that is really nice to see.
Yeah, I know I keep saying it, but I think one of my next projects, once I've redone the headlamp for the third time, is going to be something with video. I'm trying to get myself in the situation where I have an excuse to do an
Video
actual project, and
video
yeah.
and AI. It has to do AI
No,
as
no,
well.
no, no,
And
no.
I'm
Only,
only half
only
kidding.
video.
Only half kidding. Like there's some interesting things you could do if you. Um, but yeah, that's that's some cool news. I'm sure next week we will be droning under new boards, new drivers, etc., because everybody is rushing to hit the feature freeze. Basically, exactly 1 week to go. So yeah, people get your PRs, sorry, in, and we'll talk again in a week. Bye.
Bye.